Hey everyone, Professor Davis here from ChemSurvival.com and the YouTube channel ChemSurvival. And in this short video, I'm going to illustrate a simple method to help you balance chemical equations. In order for chemical reactions to be as useful as possible, they need to be balanced. So what do I mean by balanced? Well, consider the reaction of oxygen and hydrogen to form a compound called hydrogen peroxide. Now, we all know that atoms can't be divided, created, or destroyed, so we need to be sure that when we report a chemical reaction, that we're showing the same number of atoms of oxygen and hydrogen going into the system as we do of each coming out of the system. Now, of course, to write this chemical equation out, a chemist would use a different notation, one that looks like this: O2 plus H2 forming H2O2. So let's take a look at this equation and see if it is indeed balanced. To do that, I have to take an inventory of all the atoms on the left side going in and all the atoms on the right side coming out of this chemical process. In this case, I have two elements, oxygen and hydrogen. And if I go ahead and assume 1 mole of each, I find that I have 2 moles of oxygen on the left and 2 moles of hydrogen on the left as well. Turning my attention to the right side, the products that are forming in the reaction, I see that my mole of peroxide also has 2 moles of oxygen and 2 moles of hydrogen. So this chemical reaction, as written, is already balanced. But what happens when I have a chemical reaction that's not? When that's the case, we simply need to apply a 5-step method to balance the equation and get coefficients that ensure that we've represented the chemical equation with the same number of each atom going in and coming out of our chemical reaction. The simple procedure for balancing chemical equations is as follows. In step 1, we write the reaction out completely and use a coefficient of 1 for everything in the reaction. Next, we take an inventory of all the atoms on the left side of the reaction and all the atoms on the right side of that reaction. We're also going to take a look for pure elements, and if we find any pure elements in the chemical equation, we're going to lock those up and set them aside to use at the very end of the balancing process. That will make our life a lot easier. In step 4, using all the other compounds in that reaction, we change their coefficients to try to obtain equal amounts of every atom on both sides. And finally, if necessary, we unlock those pure elements and change their coefficients at the very end so that we get a nice balanced equation without knocking any other balances out of whack. Let's take a look at this method in action. Here's another reaction between oxygen and hydrogen, this time to form water. But again, a chemist wouldn't write the reaction this way. A chemist would write the reaction this way. O2 plus H2 forms H2O. But is that reaction balanced? Let's find out. We'll start by placing coefficients of 1 in front of everything, oxygen, hydrogen, and water. Next, we're going to take our inventory of atoms. In this case, we have oxygen and hydrogen that we need to consider. 1 mole of O2 gives us 2 moles of oxygen on the left side. And 1 mole of H2 gives us 2 moles of hydrogen on the left side. But on the right, we have a water molecule, and a mole of water contains only 1 mole of oxygen, but 2 moles of hydrogen. So this chemical equation is not balanced because there is not the same number of oxygen atoms on both sides. So let's go on to step 3. Let's lock up those pure elements and save them for last. In this case, we're left with only water to balance. So let's use the coefficient of water to try to correct for that deficiency in oxygen. Since I need 2 moles of oxygen on the right side of my equation, I'm going to change that coefficient on water from 1 to 2. This will change the number of oxygen to 2. But 2 moles of water also contains 4 moles of hydrogen. So in fixing the balance for my oxygen, I've now knocked the balance of hydrogen out. But I have an ace in the hole. I've saved my pure elements for last. So now it's time to unlock those pure elements and fix the problem. See, by changing the coefficient on hydrogen on the left side, I can increase the amount of hydrogen to 4 without altering the amount of oxygen. This allows me to complete balancing my equation. 2 moles of oxygen on both sides, 2 moles of hydrogen on both sides. Now let's take a look at one more, slightly more complicated example. Now let's consider one slightly more complicated reaction, the combustion of propane. Propane is C3H8, and when combusted in the presence of O2, it creates carbon dioxide, CO2, and water, H2O. But is this chemical equation properly balanced? Well, to find out, we're going to place coefficients of 1 in front of everything. And now we're going to determine how many moles of each element are on either side. We're going to take our inventory of atoms. Notice that in this case we have 3 different types of atoms we have to consider. We have carbon, hydrogen, and oxygen. On the left side of my chemical equation, I currently have 3 moles of carbon. I also have 8 moles of hydrogen. These are supplied by the propane. If I look for oxygen on the left side of the equation, I find that I have 2 moles. Now let's turn our attention to the right side of our chemical equation. I see that I have 1 mole of carbon from the CO2. I have 2 moles of hydrogen from my water, and considering all sources of oxygen, both CO2 and water, I can determine that I now have 3 moles of oxygen on the right-hand side. So clearly, I have my work cut out for me here. Neither carbon, nor hydrogen, nor oxygen is currently balanced. So moving on to step 3, I'm going to scan my equation for pure elements and lock them up so that I only use them at the very end of the process. In this case, I have elemental oxygen, so I'm going to save that one for last. Moving on, I'm going to use the compounds in my equation to try to balance each element one by one. So let's focus in right now on carbon. I have 3 carbons on the left and 1 mole of carbon on the right. So to correct for this, I can change the coefficient on CO2 from 1 to 3. Notice that doing this means that I now have 3 moles of carbon on the right side of my equation. But it also changes the amount of oxygen from 3 to 7 moles total. So I've correctly balanced my carbon, but I still have work to do. Let's move on and consider hydrogen next. I have 8 moles of hydrogen from my 1 mole of propane on the left, and I have 2 moles of hydrogen from my water on the right. So I need more hydrogen on the right side of my equation. And the only way I can accomplish this is by changing the coefficient on water. If I change my coefficient on water from 1 to 4, I now have 8 hydrogens. But again, I change the amount of oxygen in the equation as well, bringing it to a total of 10. This means that I balanced carbon and hydrogen, but have yet to completely balance oxygen. At this point, it's time to unlock those pure elements and use them to do my final tweaks to the balancing of oxygen without throwing off all the hard work I've already done getting carbon and hydrogen balanced. So let's free up that O2 for use and change its coefficient from 1 to 5. When I do this, I create 10 moles of oxygen on the left side of my equation to match the 10 moles on the right. I have balanced all 3 elements, carbon, hydrogen, and oxygen, using a simple 5-step procedure. That's all for now, everyone. I'm Professor Davis from ChemSurvival.com and the YouTube channel ChemSurvival. Happy equation balancing, and I'll see you on my next video.